Again, we're going to be recording the session this morning. Today, we're going to be doing session number 3, our furnace overview for our TMV product. Now, the TMV is going to be a variable speed indoor blower motor. And so today we're going to be doing, again, we're going to be looking at the control boards and all that sort of stuff this morning. So some of the key things we're going to be talking about specifically is control board layout like we've done before. We're going to literally go over every input and every output on the board. We're going to talk about field selection of heating off delay timings, low voltage terminal wiring, airflow adjustment, and then at the end we'll do testing flame current again. Now I know we've done testing flame current at the end of every one of our sessions, but I think it's one of those subjects that's kind of timeless, if you will, in the fact that it's always good to review testing that flame current. So this morning, as we take a look at our two-stage variable speed control board layout. Now remember, team, this is going to be on the TM8 or the TM9V furnace, and this is probably the, I won't say the most complex, but it has the most features on it of any of our furnace control boards, in the fact that, we're going to have some two-stage heating, two-stage cooling capability. And the neat thing about this board is that because the motor is a true variable speed, high efficiency motor, we're going to have some airflow adjustments on the board that we'll be talking about as well. So starting out over on the left-hand side, like we normally do on the low voltage terminal strip, C is going to be our 24 volt common. This is where we're going to hook up our thermostat and our low voltage wirings. G will be our fan call. This is pretty conventional, isn't it? And so again, just very, very straightforward. R is 24 volt hot. W/W1 is going to be our first stage heating call. Now, it's really important that if for some reason you're stuck with a single stage thermostat, we always want to make sure we land our heating wire on a single stage thermostat on this W/W1 terminal. Because this board, like our previous board we talked about last time, it does have some staging capability. And so let's say, for instance, you're stuck with a single stage thermostat, you don't have enough wires behind the wall. Maybe the homeowner just really, really likes that old Honeywell mercury bulb thermostat. This thing would be compatible with that as far as on the heating side. So literally, if I have a single stage thermostat, I can put it on W/W1 and still get some staging capability off of the board, which we'll discuss later on. Now, team, we always recommend that you, if you have a two-stage heating product, make sure and put a two-stage thermostat on there, for the ultimate comfort and for the fact that, it's going to give you the most functionality. But we also know in the field, sometimes you're just stuck with what you have. So if you are stuck with a single-stage thermostat, be sure and land it on that W/W1 wire for that first stage heating. Y/Y2 is going to be our second stage cooling call. Again, this board is actually set up for a two-stage heat, two-stage cooling operation. Y1 will be our first stage cooling call if you have a two-stage product outside. And by the way, maybe make a little mental note of this. We have a product called a TH16, which is a 5-stage 16 SEER product that's perfectly compatible with this board. As a matter of fact, this board is extremely versatile. This furnace is very, very versatile. You can literally hook this thing up with anything in our inventory as far as, single stage, two-stage, or what have you. Very, very versatile product. W2 is our second stage heating call. And again, team, we're going to recommend that if you have a two-stage furnace, always plan on a two-stage heating thermostat for the ultimate comfort and control. Now, this is a little bit interesting because this is a variable speed product. We have what we call a dehum cooling terminal. Now, what this is a dehumidification terminal that we can use in the cooling mode of operation. And so how this works is if you've got a humidistat hooked up to the dehum and the R terminal, in other words, you just put a humidistat between R and dehum, what will happen in the cooling mode of operation, if it's humid in the house, the contacts will be open on a rise of humidity, and it'll actually slow the indoor fan down in the cooling mode of operation to provide dehumidification for cooling. And then once the house dries out in the cooling mode, once the house dries out, the humidistat will close electrically on a drop of humidity and energize this dehum terminal, And when we energize the dehum terminal, what will happen is it will allow the fan to come up to full speed in cooling mode. Now, there's going to be a jumper selection a little bit later on we're going to talk about. And so if you want to utilize this, you're going to have to tie in, you're going to have to move a jumper for the humidistat yes, no, or yes, you want to use that function. It comes from the factory in the no position on the jumper. So that terminal is not energized. It's not going to be used unless you select it. So be sure if you want to have extra dehumidification, you select that humidistat yes jumper, and then and just remember that you have to have a humidistat on that dehum terminal between dehum and R terminal, 24 volt hot. Otherwise, what will happen if you have the jumper in the yes position and you don't use this, your fan will never get above 80% airflow. So this is really important, you know, during your startup and commissioning, to make sure if you're not going to use this, that your humidistat jumper is in the no position. And again, we'll show you that jumper a little bit later on when we start setting up our airflow. So this is, like I said, kind of a neat little function for extra dehumidification in the cooling mode if you want it. Any questions or comments so far? Everybody good? Thumbs up? All right. Because this is a variable speed product, we also have an O terminal on there. And what that means, if you see an O terminal on a furnace product like this, what that automatically tells you is this furnace control is set up or optimized for a dual fuel heat pump operation. And again, this is one of those things, if you're going to have this on a heat pump outside, you're going to have to move a jumper to tell the board to look for an input on this O terminal. O terminal is going to be for a cooling mode of operation on our heat pump product if you have a dual fuel product. Now, this is really important. If you're not going to put this on a heat pump, there's a jumper you're going to have to select that says AC or heat pump. Now, it comes from the factory on AC. However, we have had some field calls in the years of experience I've been with Johnson Controls that, you know, we had one or two boards, maybe a replacement board that was on the heat pump jumper. And it doesn't hurt anything. It certainly doesn't burn anything up or anything like that. But if you have the heat pump and the AC jumper in the heat pump position, and again, we'll talk about this jumper more when we start getting into jumpers, but just kind of make a mental note that if you have it on a heat pump, you have to have it on the heat pump position. But if you don't have it on a heat pump, make double sure when you commission this board that if it's not on a heat pump, that it's on the AC jumper. Because if it's not, what will happen is if you have it on the heat pump and you don't have a heat pump hooked up outside, it'll throw a flash code that says, hey, I'm getting an O signal, but we don't have a heat pump outside. So just kind of keep that in the back of your brain. It's just one of those little things that you need to double check when you commission the board to make sure that you don't have that jumper in the heat pump position, because if you put it in the heat pump position, it's going to be looking for an input on O terminal, which is the cooling mode for the reversing valve on a heat pump. Any questions or comments on that before we continue? Everybody good? Okay. So as we move around the board, on the top of the board, as we look at it in our photo, we're going to have a place for a fuse. And I don't know why I don't have a fuse on this particular picture, but anyway, that's where the fuse goes. It's just up to a 5 amp fuse. We typically ship the board with a 3 amp fuse, but in this case, you can go up to 5 amp. If you had some 24 volt accessories, you know, that were pulling down a little bit higher amperage on the thing. As we move around the board, we see we have some communication screw terminals. So this is pretty cool as well. This is a variable speed blower control, but this control board is also compatible with a 4-wire communicating system. So let's say, for instance, you've got a 19 SEER unit outside that you want to go 4-wire communicating, or maybe you don't have enough wires behind the wall. So this is a really slick little upgrade. You can set this up with our communicating thermostat and just bring 4 wires down from the thermostat and hook it up to your communicating terminals, and then communicating 4-wire going outside to like a 19 SEER product. So this control board is literally compatible with anything in our inventory. You can hook this up. You can hook this furnace up to anything in our inventory except the momentum the momentum unit that's going to require the modulating is what we typically have you hook that up with. But as far as anything else, the 19 SEER all the way down to 13 SEER, you could hook this thing up. Works very, very well. As we move around the board, you're going to see there's a status LED. That status LED is a tricolor LED. In other words, it's going to flash one of three colors. It'll flash red, green, or amber, or yellow. I like to call it yellow, but the amber. So red, green, or amber based on the flash code that the board is seeing. Now, it should be noted, the control board, if you have any faults on the control board, you can retrieve those faults by pushing a last error button, which we'll show you that in just a second. But please remember that it's going to remember the last 5 faults, or the last most current 5 faults. So if you have 8 faults on the board, for instance, it just remembers the last 5 for you. And then to reset that board, if you'll hold that last error button down for about 10 seconds, it'll reset that memory. And that's just good practice, fellas. If you get out on a field call and you see if you've got some errors on the board, to clear those errors up before you leave the job site is what I typically do or recommend. So be sure and hold that last error button down when you're done servicing the product and clear that memory so that you'll always have the freshest faults on there if you happen to have faults. We have a CFM LED. Now this is kind of a cool little thing too, in the fact that the variable speed products, we're going to provide you with a CFM LED. Now that CFM light will flash one time for every 100 CFM that's programmed on the board. So in other words, it doesn't matter if it's in the heating mode, it doesn't matter if it's in the cooling mode of operation, doesn't matter if it's first stage, second stage, doesn't matter. Whatever CFM is programmed on the board, that indoor blower, because it's a variable speed motor, is going to ramp up and down to meet that CFM that you have programmed on the board with your jumpers, which we'll talk about in a little bit. But this little light right here is just a quick little visual cue. Anytime the fan is running, that CFM light is going to flash one time for every 100 CFM. So if you're taking a look at it, and let's say it's flashing 10 times, that if it's flashing 10 times, that tells you you're blowing 1,000 CFM. If it flashes 12 times, 1,200 CFM, and so on. So one flash of the LED equals 100 CFM. Any questions or comments so far on what we're looking at on the control board? Everybody good?
We're good on this.
Okay. Now, if you have a communicating system, you'll notice there's another green terminal block here. So if you have a communicating system, we give you some optional terminals to hook up some accessory devices. Because remember, if you've got a communicating system, it's just a 4-wire hookup. But you have some optional temperature switches, auxiliary, and float switch terminals. If you have a communicating system, that if you want to have like an auxiliary float switch, for instance, instead of just cutting power to the board like you normally would, or like some wiring schemes may be, you just shut the power off if you have a float switch issue, or you kill the Y terminal if you have a condensate float switch trips off, it kills the condensing unit outside. Well, you don't have to take any wires off or break any wires with this. So if you have a communicating system, you can hook up an accessory float switch. For instance, this is just one of the things you can hook up. Hook up an accessory float switch. It'll go ahead and tell the board that you've got a condensate issue or you've got a float switch issue. So you've got some optional terminals there if you're running a communicating system. Right next to that, you're going to have a 6-pin ECM motor plug. Now what that is, it's actually an output from this board down to our ECM or our high efficiency motor. Now whenever you see ECM, that means it's a high efficiency motor, and so that is correct. So a variable speed motor is a type of an ECM motor, but instead of having physical jumpers on the motor like we spoke about with our last product on our TM9Y or TMY product, where you're actually going to go down and physically move jumpers on the board, jumpers on the speed taps on the motor itself. The variable speed control board is a totally different control scheme. So here we're going to have a 6-pin plug that's going to go down and tell the motor what to do. And all of our airflow jumpers are going to be jumpered on this board right here. So we're not going to be going down to the motor and making speed tap changes with this type of control scheme. We're going to just tell the motor what to do by way of this 6-pin plug. And then any airflow jumpers or any airflow measurements or airflow adjustments we want to make, we're going to make down at the bottom of the board with airflow jumpers, which we'll discuss here shortly. Here we have a neutral plug, a 6-pin neutral plug. And you'll also notice beside that 6-pin neutral plug, you're going to have a couple of accessory spade terminals. And that's in case you have something, let's say you have a humidifier or you have a some accessory device that you're going to plug in and you need an extra neutral. So we provide that on the board with our 6-pin plug, but also a couple of accessory neutral spade terminals in case you have an accessory that you want to hook up. Coming down the side of the board, you're going to notice there's a 5-pin plug. Now that 5-pin harness, what it does is going to feed 120 volt to our, for instance, like our transformer primary and our hot surface igniter, as well as our high and low inducer speeds. So this is all again going to be harnessed in from the factory team, but I've taken all the harnesses off so we can talk about all the features on the board. But this is where we have this 120 volt output to our transformer primary, our hot surface igniter, and then our high and low on our inducer draft blower as well. As we move down the board, you're going to notice we have a 120 volt output for a humidifier. And so anytime you have a heating call generated on the board from the thermostat, you'll have an output on that HUME terminal. And that HUME terminal, by the way, is 120 volt. And so if you want to power a humidifier right off the board, you can do that. And this is something I really kind of like about our Champion product is, we give you accessories on the control board itself, to hook up like a humidifier, an electronic air cleaner and stuff like that, because, a lot of manufacturers, what they'll do, you have to have a separate relay pack, or you have to have a, separate power source or whatever. So this is kind of cool. This is one of the things I like about our controls quite a bit, is the fact that, we give you a lot of these accessories already built in on the board. And so in this example here, that HUME terminal is going to be an output that's going to be energized anytime you get a heating call if you want to power up a humidifier during your heating call. You'll notice right to the left of it, there's a little black relay box right there. Let me move my cursor around a little bit. So right here, this little relay right here is actually an isolated relay for that humidifier output, which is kind of neat because now you're not pulling 24 volts over here off the terminal strip. You actually have an isolated 120 volt output right there on the board for a humidifier. Same way with the electronic air cleaner. You'll notice on the electronic air cleaner, right beside the electronic air cleaner, there's a little relay right here, and that's an isolation relay, so that electronic air cleaner will have 120 volt output to it anytime you have a G call or the fan is running. So if the fan's running, you're going to automatically have an output on there for an electronic air cleaner if you so desire to use that. Now, please bear in mind, if you're using an electronic air cleaner in this example, that's a 24 volt electronic air cleaner, you're going to make sure and take the 120 volt off of this, and you're going to provide another transformer, a step down transformer. So that's how we normally see this, taking place. If you have like a Honeywell or an Aprilaire, for instance, electronic air cleaner that's 24 volt input, what you do is you come off that EAC terminal with a transformer, a low voltage transformer, step it down to 24 volts, and then take that 24 volts over to the air cleaner. Now this is really important. The reason I'm making a point of this, we don't want you grabbing 24 volts off the terminal strip to power up, to go ahead and power up for instance, like a 24 volt air cleaner or a humidifier. That's why we give these isolated relay outputs. So if you do have a 24-volt humidifier or a 24-volt electronic air cleaner, be sure and take a step-down transformer off of these terminals here that are 120 volt, and then step it down for your, your accessory product, whether it be a humidifier or an electronic air cleaner. Does that make sense to everybody? Any questions or comments on that? Everybody good?
We're good.
Okay. All right, now here's our flame current pad. You'll notice that it's in a little different position than it was on some of the previous products that we've talked about. In this particular case, the flame current pad is at the bottom of the board, but don't sweat that. It's the same function as every other flame current pad we've talked about. So basically, instead of having, you don't have to have a special meter. So instead of having a special meter for reading flame current, you just take your plain Jane voltmeter that you've got in your truck, put it on DC volts, and then go down to that flame current pad. And if you read 1 microamp DC is equal to 1 volt DC. So on your meter, you're going to read 1 volt DC for every microamp DC that the flame sensing circuit is putting out. So this is very, very handy. We feature this, by the way, on all of our Champion furnaces. We have a flame current pad for your convenience. But that's where it's located on the board. On this particular board is at the bottom of the board down there. Here's our 12-pin harness at 24-volt input-output. And this, again, will all be harnessed in from the factory. We just took the harness off so we could see it in the picture. But this is where we're going to have inputs and outputs to our pressure switches, over to our gas valve. All of our safety circuits will be harnessed in right here. So it's kind of a convenient place to know that, your 24-volt input outputs will be tied in right here. Typically what they'll do also is they'll actually have an output on here on this 12-pin harness for your flame sensor as well. So all those things, flame sensors and safety circuits and stuff like that will harness right in here in a nice convenient place to where you can, pull that harness apart, look it over, take it off, look it over, make sure the pins are clean, make sure the wires are in good and tight, and then snap it back on. So that's kind of a nice little convenient spot for all that. One of the things that we did, team, is we wanted to make sure that we spent a little extra time. What we did specifically, because sometimes we get some pretty good questions on these boards, and so I wanted to spend some extra time on the airflow jumpers. That's why we allotted a little extra time this morning. And so please, if you have any questions on these airflow jumpers and how we're setting them up, we want to make sure and talk about that. So let's go ahead and, because it's a variable speed control board, we're going to have physical jumpers that we can move on the board to really tweak our airflow and to really tweak our unit to just exactly what we want. You'll notice a lot of these jumpers have like an A, B, C, D type of configuration. Some of them say yes, no. Some of them are a time. We'll get into all that. But the first one we want to talk about is what we call the delay jumper. The delay jumper is actually a cooling on delay function. And so based on your local geography, for instance, I happen to remember that the B is for humid. And I like to remember that because I live down here in Mobile, Alabama. So B for Mobile, right? And so the B configuration, what that does is it sets the airflow in now this is cooling on delay function. So based on your geography, we have A, B, C, and D. And if you look in your service information that comes with the equipment in the install guide and technical guides, you're going to find that this is very, very well explained. But as a quick overview, what it does is when the fan starts out, for instance, in a cooling mode of operation, we'll just talk about the humid profile because, like I said, that's one I happen to remember. So what will happen anytime you get a cooling call on the control board, it doesn't matter if it's first stage cooling or second stage cooling. What will happen is the fan will start out at 50% airflow and it will hold that for like 1.5 minutes. It'll then ramp up to 82% airflow, percentage of airflow. It'll ramp up to 82%. It'll hold that for another 6.5 minutes. Then if the call for cooling is still there, it'll ramp the fan up to 100% airflow until the call for cooling goes away. Once the call for cooling goes away, it ramps the fan down to 50% airflow and holds it for another 1.5 minutes, and then it'll shut the fan off. So this ramping profile, what it does, by having that fan running slow in the cooling mode, for the first 1.5 minutes in the cooling mode, it really gets that evaporator coil really cold. So let's think about that. If I've got a 3-ton unit sitting outside, and I would be normally blowing 1,200 CFM on a 3-ton unit, and then I have that jumper set in the B position, the humid profile, what's going to happen is for the first 1.5 minutes, that thing's going to be blowing 600 CFM with a 3-ton unit sitting outside. And so that's going to really, really chill that evaporator, really get that evaporator really, really cold, for that first 1.5 minutes. Then we're going to ramp it up to 82% airflow, still keep the airflow down. We don't want to freeze the coil up, but keep the airflow down for another 6.5 minutes, so we have a really cold evaporator. So basically, every time this thing goes into the cooling mode, if you happen to have that jumper in the B position, every time it goes in the cooling mode, you're going to have reduced airflow on the beginning of the cooling call, and to really chill and really get that evaporator very cold. Now, here's why we do that. Now, remember, team, what happens whenever you have a really cold evaporator coil in the cooling mode, you're going to start really pulling a lot of moisture out of the air that's going across that coil. And so that's the control scheme. We want to dehumidify quickly at the beginning of the cooling call, and then once the cooling call is over, we're going to ramp that fan down again to 50% airflow, again to have really cool air off the thing, and then we shut the thing off. So that's just one example of the delay profiles that you can select. So A is normal. A's, it comes from the factory. A is normal, and what that is, it ramps the fan up, say, and I don't remember them all exactly, but let's just say in the normal mode of operation, it takes 1.5 minutes to ramp the fan up to 100%, and then 1.5 minutes to ramp it down. In the B profile, that's a humid profile. We just talked a little bit about that real nice delay on the front to get a lot of moisture out of the air. I think the C profile is what we call a dry profile. If you're out in the desert of, the high deserts of New Mexico, and you don't have any humidity out there, but you want your fan coming on right away, it'll ramp the fan straight up, like over 10 or 15 seconds, and 100% airflow. And then when the call for cool goes away, it just ramps the fan down, quickly, maybe 30 seconds and so on. So the idea is this delay profile gives you the option, based on your local geography, to really have a cooling on delay profile to help control moisture or to have added capacity for the unit and so on. And so again, this is very, very well explained in the install or the technical information that comes with the equipment, but we just wanted to review that real quick for you, that you have some really nice airflow on delay, cooling on delay functions by way of the delay jumper. Any questions or comments on that? Everybody good? Now, just real quick, who has set those up before? Who's put in some variable speed stuff before? You guys put some variable speed stuff? Okay, so you're familiar with that delay operation and how you can really kind of tweak that to improve that comfort in the cooling mode. The next jumper we're going to talk about is our adjust jumper. Now, if you take a look at your install information, I believe we find that on page 36. That, and I apologize, I forgot to take that off the PowerPoint, but I think it's on page 36. So please kind of ignore that, because it might be on page 38 now, or it might be on page 34 in the install information. Since I've done this PowerPoint, it'll be found in your install information. But what that is, that adjust jumper works with the cool jumper. So let me say that again. The cool and the adjust jumper, they work together to set up your cooling airflow. Now, please note this. When you take a look at your install information, and again, it used to be housed on page 36. It might still be page 36. But as you take a look at your install information, you're going to find that the cool and the adjust jumper, they work together to set up your cooling airflow. Now, please make a note of this, or a mental note of this. The cool and the adjust jumper is your Y2 airflow. Let me say that again. When you set up your cool and your adjust jumper, you're setting up your Y2 or your high speed airflow. If you have this on a two-stage unit, if you have it on a two-stage unit and you set up, let's just make it simple. Let's say we have a 2.5 ton unit sitting outside, and we always set our airflow up for high speed cooling at 400 CFM per ton. So if I have a 2.5 ton unit outside, just for simplicity, that means we're going to have our Y2 airflow at 1,000 CFM. 2.5 ton unit outside, 400 CFM per ton, that's 1,000 CFM in my example. So let's say we have a 2.5 ton unit outside, so we set the cool and the adjust jumper up for 1,000 CFM. You know, we look at our install information and we set the cool and the adjust up for 1,000 CFM. Now, hang on a second. We've got a two-stage unit sitting outside. We have a 19 SEER system sitting outside, and we get a Y1 call on this board. The board is smart enough to know that if you're set up at 1,000 CFM, if you have a Y1 call all by itself, it's going to be 65% of your high-speed cooling. So if you have your cool and your adjust jumper set up for, again, in my example, 2.5 tons, 1,000 CFM, and you have a Y1 call on the board all by itself, a Y1 call for first stage cooling, it'll automatically run the fan at 650 CFM. And then when I get a Y2 call, the fan will ramp up to 1,000 CFM in my example. So please keep that in mind. When you set up your cool and your adjust jumper, you're always setting that up for your Y2 or high speed second stage cooling call. Now hang on a second. What if I only have a single stage unit setting outside? So if I have a single stage unit setting outside, I'm going to automatically utilize on the control board, I'm going to automatically utilize the Y/Y2 terminal only. Let me say that again. If I have a single stage unit outside, you won't even use the Y1 terminal on the board. You'll go strictly to Y/Y2 if you have a single stage unit outside. So please keep that in mind with this control. If you have it hooked up to a single stage cooling unit outside, do not use the Y1 terminal, because if you use the Y1 terminal, it's only going to be 65% airflow on a Y1 call. And so we've actually had that. We've actually had some contractors call in and say, "Hey, I'm not getting my full airflow on my unit outside." Well, what terminal did you use for your cooling call? Well, Y1, because I got a single stage unit outside. No, don't use Y1 at all if you have a single stage unit outside. Because remember, this cool and adjust jumper, we're setting up our Y2 airflow for full airflow. Any questions or comments on that? Everybody good? All right, just wanted to clarify that, make sure everybody had that. Okay, so as we come down, we see we have a heating jumper on the control board, the heat jumper. Now, the heating jumper, as its name implies, is to set up your heating airflow. Now, from the factory, it's going to be set up to have the appropriate airflow, you know, for the heat exchanger and the size of the furnace. Now, we always set these up, by the way, at the maximum airflow, because we don't know what your duct system is going to be like out in the field. But to optimize your heating airflow, be sure and take a look at the data plate on the furnace. And then you may want to make some adjustments on this, especially if you have a really nice, you know, wide open duct system where you have a very low restriction on your duct system. And you may want to adjust that a little bit for ultimate comfort. Now, please remember, on the data plate, if you take your service information on the furnace and you pull your service panels off the furnace, you're going to notice a data plate. Always make sure and set up or tweak your heating airflow so that it's in just about in the middle of your temperature rise. Now remember, team, to find temperature rise, you're going to take your supply air temperature and your return air temperature and find the difference. So let's say we have 140 degree supply air temperature and 70 degree return air temperature. Well, my temperature rise in that example would be 70 degrees. And so look at your data plate, and you can tweak your airflow for heating by utilizing those heating airflow jumper, or that heating airflow jumper down there. Now remember, team, we always ship it on the highest airflow possible because we don't know what, the condition of the duct system is going on. So during your commissioning, your startup and commissioning, you may want to adjust that a little bit. Instead of blowing a huge amount of air, you maybe want to lower that airflow a little bit for comfort. But again, make sure and look at that data plate on the service panel of your furnace. Do a temperature rise measurement, and then set up your airflow so it falls right in between our temperature rise. Now, typically on our data plate, you're going to notice we're going to have a pretty wide range. The temperature rise on the data plate will be somewhere between about 40 and 70 degrees. So if you set that up to where it's right in the middle, you'll be exactly on where we like you to be on the furnace. Any questions or comments on the jumpers we've talked about so far? Everybody good? Okay. There's that humidistat for cooling. Remember we talked about over there where we had the dehume terminal. So that humidistat for cooling, if you want to utilize that dehume terminal, you're going to put that jumper in the yes position, and then make sure you have a humidistat hooked up between R and dehume on the low voltage terminal. If you're not going to use that dehumidification for cooling function, make sure that is in the no position. It comes from the factory no, but make sure it's in the no position if you're not going to use that dehume function on the low voltage terminal strip, because if you have it in the yes position and you don't have anything hooked up to the dehume terminal, it will never allow the fan to go above 80% airflow. Because remember, Tim, we talked about that, a less airflow, colder evaporator, more dehumidification during our cooling cycle. But what will happen is if you have that in the yes position, make sure you've got a humidistat hooked up between dehume and R. Otherwise, you'll never get your fan above 80%. If you're not going to use that function, double check during your startup and commissioning that the humidistat jumper is in the no position if you don't want to use that function. Right below him, you've got your heat pump, yes, no. And again, this configures the board for an O terminal for a heat pump. If you have a dual fuel situation, if this furnace is set up with a heat pump, you can go ahead and configure it for a heat pump so that that board looks for the O terminal in the cooling mode. And again, if you have a straight AC unit outside, double check to make sure during your startup and commissioning, make sure that that jumper is in the no position on the heat pump. Otherwise, it'll throw a fault if it doesn't see anything hooked up to O terminal. So if it's on a heat pump, put it on yes. If it's on straight AC, make sure that that jumper is on the AC position, or heat pump, I should say, the heat pump no position if it's on a straight AC. Over here we have what we call fan speed. Fan speed. Now what that is, that fan speed is for your continuous fan if you have a G call only. Let me say that again. The fan speed, it gives you some nice functions for continuous filtration in the home. So let's say, for instance, the homeowner they've got a nice electronic air cleaner, and they want to circulate air in the house all the time. So they go over to this thermostat sub-base assembly, and they go from auto to on where it says fan. They flip the fan on all the time. How fast is the fan going to run? Well, that's what this jumper is all about. So you have the ability to set that continuous fan airflow with a G only call, high, medium, and low. Now remember, this is a variable speed product, and so this high, medium, low is going to be a percentage of high cooling airflow. So high speed cooling airflow. So high, medium, low. So low is going to be 50%. Medium is going to be about 65 to 70% based on the model. And then high will be 100% cooling airflow. So again, it's going to look at your cool and adjust jumper to see how much your cooling airflow is, your high-speed cooling airflow. And then high, medium, and low is going to give you a percentage of your cooling airflow if you have a G-only call. Again, low's 50%, medium's about 65 to 70%, and then high as 100% cooling airflow. So that gives you some nice little options there. Any questions or comments so far before we talk about the last couple jumpers? Any questions? Everybody good? Okay. Down below that, we have a blower delay, and this is used for heating off delay. Now remember, Tame, once the call for heating goes away, your furnace is going to continue to run a little bit to cool the heat exchanger down and to distribute whatever residual heat you have on the heat exchanger into the conditioned space. So how long that blower runs after the call for heat goes away is going to be determined by this jumper. You'll notice if you look at it closely, it's going to be like 60 to 180 seconds. And so we typically ship it at about 120 seconds, a 2-minute off delay. But you can go up to 180 seconds, a 3-minute off delay, or you can go down to 60 seconds, minimum 60 seconds, for a 1-minute off delay. So let's say it's all about it. It's just a comfort jumper. You know, let's say the homeowner says something along the lines of, you know what, I really love your furnace, but you know, every time it shuts off, I notice the fan's running for a couple of minutes and it seems to start blowing some cold air, and I don't like that. Can you do something about that? Sure, you take it down to 60 seconds and so on. So you get the idea. So you can adjust your you can adjust your heating off delay with this field selectable jumper that says blower delay. And again, we normally ship that at about 100 to 120 seconds from the factory, but you can go down to 60 or up to 180-second off delay. The final jumper that we have on our board is what we call a staging jumper. Now remember, if you're stuck with a single stage thermostat, you know, it'd be kind of nice to have some staging function, right? Well, this is actually what this is. This is a staging jumper if you're stuck with a single stage thermostat. So there's going to be some positions on it. It's going to be like 10, 15, 20 minutes and off. Now this is really, really, really important. If you're stuck with a single stage thermostat, make sure it's on something other than off. Because if it's in the off position with a single stage thermostat, in other words, all you have hooked up is W1, W/W1 on the board. Yeah, you're stuck with a single stage thermostat. You don't have enough wires. The homeowner doesn't want to change the thermostat for whatever reason. You're stuck with a single stage heating thermostat. If that's in the off position, you will never get out of first stage heat. Let me say that again. If this jumper is in the off position and you're stuck with a single stage thermostat, you will never get out of single stage heat. However, if you have it on 10, 20, or 10, 15, or 20-minute jumper, what will happen if you're stuck with a single stage thermostat, and let's say it's on the 10-minute position, and you get a call for heating on W1. If the call for heating is still there after 10 minutes, it'll automatically go to second stage to finish off the heating call. Then it'll shut, you know, once the thermostat's satisfied, it goes through its normal shutdown procedure and so on. So the staging jumper gives you some options if you're stuck with a single stage thermostat. Now, team, we always recommend you have a 2-stage heat, 2-stage cool thermostat, right, on this product. That way you have the ultimate comfort and stuff like that. But if you are stuck with a single stage thermostat, we do give you some staging options, but make sure that if you're stuck with a single stage thermostat that you've got it on something other than off. Because if it's on off one more time, just remember, if it's off, you'll never get out of single stage heating. Any questions or comments on the jumpers before we cover one more little point, and we'll take some questions after that?
No, we're good.
Everybody good? Okay. The final component on this board I want to talk a little bit about is what we call our Model ID plug, the Model ID plug. And what that is, it's just a plug that has some simple wires on it. You know, it isn't like a personality module or a jump drive or anything complicated, or a USB or anything like that. It's just a simple wired plug that tells the control board what size furnace it's hooked up to. And so now instead of having 47 different boards on your truck, basically you have one replacement board on your truck, and or you buy a replacement board, and that Model ID plug tells the board what size the furnace is. And so please note that if you have to have a replacement board, if you have to replace a board, be sure and take the model ID plug off the old board and snap it onto the new board. And then as soon as you power that board up, that new board, the very first time, what will happen is the control board will then know what size furnace it's hooked up to. Now, it's been a while since I've seen any replacement boards, but I'm thinking we ship, with the replacement board, I'm thinking we ship more model ID plugs based on, on your need. But if you don't have extra model ID plugs, be sure and take the old model ID plug off the old board, snap it onto the new board, so that when you power it up the first time, the new board knows what size control board it's hooked up to. Now, it should be noted, all of your jumper selections, your cool and your adjust and your delay, the board wouldn't remember any of that. This is strictly for a model ID. So all this plug does, it doesn't remember any of your jumper settings. All that model ID plug does is it configures the board for the size of the furnace that it's hooked up to. Any questions or comments on the control board before we kind of open the floor up for any final questions or comments? But that's pretty much our rundown on our two-stage variable speed board this morning.
No, we're pretty good.
In good shape? Okay. Well, I'll tell you what then. Let's talk a little bit about measuring flame current again, just to review that real quickly, and then we'll take any final questions or comments you might have, and then we'll go ahead and secure for the morning. So measuring flame current, as we said before, is very, very important. And so let's just jump in there just as a quick review. As a quick review, remember, team, anytime you have power to the board, let me say that one more time. Anytime you have power to the board, we're going to be putting 115 volt to the flame sensor. Now, it should be noted this voltage, even though it's line voltage driven to the flame sensor, it's not going to shock you. It's not going to hurt you. It's not going to burn anything up if it shorts the ground, because it's an extremely high resistance circuit. So even though it's line voltage driven, and we have AC voltage going to that flame sensor, anytime we have power to the board, it's an extremely high resistance circuit. Now, if a flame is absent, if we have no flame, nothing's going to happen. There's not going to be any current flow or anything like that. But watch this. As soon as you start a flame, or as soon as you have flame on the burner, what's going to happen, if the flame is present, that AC voltage is going to go through the flame, down to chassis ground, and back to the board. And so the flame actually rectifies or converts that AC voltage to a DC voltage. Now that direct current is going to be sensed, or that DC is going to be sensed on the ground plane, and then gas will continue to flow to the burner. Now it should be noted, if you take a look at this little graph, it's actually a pulsating DC along the ground plane. But this is why it's really, really super important that you have a really good, clean ground on your furnace. And you want to make sure that the furnace is grounded. It has a good solid ground to earth ground and so on, because it's part of your flame sensing circuitry. So it should be noted, you got to have a good ground, but it also, the polarity has to be correct on the furnace as well. So if you have reverse polarity between neutral and hot on the furnace, what it's going to do, it's not going to burn anything up, it won't hurt anything, but the board will not be able to see or sense the flame if the polarity is backwards or if you have a poor ground. So it's really, really important every year or during your cleaning check, clean that flame sensor. Make sure the ceramic on it is not cracked or anything like that. And I recommend using steel wool or stainless steel wool to clean that flame sensor. Don't use sandpaper, because you can deposit little pieces of sand on there, and then of course when you start the flame up, that sand can actually melt into a real fine little coating of glass. And so, because that's what glass is made out of, is sand. And so be sure and clean that flame sensor with steel wool. Scotch-Brite works pretty good too, but do not use sandpaper, please. And testing, or actually measuring flame current, what you're going to do, you're going to call for heat and let the furnace establish normal flame. So just call for heat. It doesn't matter if it's first or second stage heat. Just let it call for heat and establish normal flame. And then take your voltmeter and set it to DC volts. And I recommend a lower scale because it's going to be a fairly low number. And then measure your DC volts on the flame current pad. Now remember, team, 1 volt DC is equal 1 microamp DC. Please write this down and remember it. Typical flame current on these furnaces runs somewhere between about 2.5 to 4. And if you take a look at the service information, I think they'll tell you 3. But it's been my field experience that normal flame current normally runs about 2.5 to 4. Now it should be noted the flame current has to be above 1.5 microamp. If it's below 1.5 microamp, it's going to generate an amber flash code to tell you that you have low flame current. And so 1.5 is the threshold where you get the flash code. Typical flame current runs somewhere between about 2.5 to 4 has been my field observation. Any final questions or comments before we secure this morning?
Nope, you did a very good job.
Well, thank you very much. I appreciate everyone's attendance this morning then. I know you guys are going to be busy, got some things to do, but thank you so much for training with us. And we will see you next time. Have a great morning and please be safe out there.
Thanks, Joel.
You bet. Have a good morning.